Okay, so today we're going to do 6.2 on substitution, and just kind of a little bit of a review. Substitution is the process of replacing one variable with something of equal value. So here's an example of how we did it way back at the beginning of the year. We would say, okay, if x equals 5, how would you find the value of 3x minus 8? So we would take that 5 and we would substitute it back in. So we would say 3, and then replacing the x with 5, right? So we'd have 3 times 5 minus 8, so we'd get 15 minus 8, which would be equal to 7. So 3x minus 8 would be equal to 7 when x equals 5. So what we want to do, we're still working with systems of equations, so just a reminder, in the last class we talked about solving system of equations by graphing. Remember, we had 3 choices. So remember the first choice, if the lines crossed, then we had one solution. If they ended up being the same line, we said they had infinitely many solutions. And if they had parallel lines, then there would be no solution. So we still have that true, just in this lesson, we don't have to graph them. We're not graphing them this time, and this is a more precise way of solving. Okay, so let's take a look. I have y equals 2x and x plus y equals 3. Notice y is isolated. And what is y equal to? It's equal to 2x. So what we're going to do is we're going to replace y with 2x in this equation. So basically we're going to put 2x where the y is. So I'm taking this equation. We have x plus, instead of y, we're going to replace that with a 2x, and then equals 3. So we keep that equation all together. The reason we do this is we want to come up with an equation with just one variable. All right, so let's go ahead and solve. We're going to combine like terms. We get 3x equals 3. Divide both sides by 3. And we get x equals 1. Now, we're not finished here. Okay, so once we get x equals 1, remember when we had a solution, that means that we have to plug it back in to find out what the y value is. We're always going to have 2 values. All right, now you can plug into either equation. I'm going to use the y equals 2x. I think that one's easier because it's already solved for y. And I'm going to plug in x equals 1. So I get y equals 2 times 1. So y equals 2. That means my solution is the ordered pair 1, 2. We put the x first and then the y. All right, now if you wanted to, you can write out x equals 1, y equals 2, but I prefer writing it as an ordered pair. Okay? All right, take a look at B. So I have y equals 3x. So I'm going to take 3x and I'm going to plug that into the second equation. So I'm going to have x plus 2 times 3x equals negative 21. So I'm taking that second equation and the only thing I'm changing is the y turned into a 3x. Let's go ahead and multiply this. So we get x plus 6x equals negative 21. So we have 7x equals negative 21. And we get x equals negative 3. Again, this is only half of our solution. So we got x is negative 3. Now I'm going to plug it back into either equation. Of course, plugging it into the y equals 3x is easier. So we have 3 times negative 3 gives us y equals -9. And now let's put it together. Put -3, -9. Okay, maybe you want to pause it and see if you get the same answer as me for the next one. I have y equals -4x plus 12, so that's what I'm going to replace in the second equation. So I have 2x plus a -4x plus 12 equals 2. So that's going to give us a -2x plus 12 equals 2. I'm going to subtract 12 from both sides. So 2 minus 12, that's going to give us -10. And when we divide both sides by -2, I get x equals 5. Okay, now I'm going to use that first equation, y equals -4x plus 12, and I'm going to replace the x with 5. So we get -20 plus 12, and that's going to give us y equals -8. So put the two numbers together, and we get 5, -8. Now looking at D, all right, this time we do not have a variable isolated. So what we want to do is isolate a variable first. Now I see that x does not have a coefficient. So it would be relatively easy for me to take that first equation and just add 2y to both sides. So I get x equals 2y minus 3. Now, I can take 2y minus 3. This time, that's what x is equal to. So I'm going to substitute 2y minus 3. I'm going to replace that where x is. So I have 3 times 2y minus 3 plus 5y equals 24. All right, go ahead and solve for y. We're going to distribute, so 6y minus 9 plus 5y equals 24. I'm going to combine those. And we're going to add 9 to both sides. So I get 11y equals, that's going to give us 33. Divide both sides by 11. And we get y equals 3. Now, I can plug it back into either equation. I'm going to plug it into the first one. So I have x minus 2 times 3 equals -3. It's going to be x minus 6 equals -3, so I'm going to add 6. And we get x equals 3. So x equals 3, y equals 3. So my ordered pair is 3, 3. Okay, so next what we want to do is look at what happens when there are infinitely many solutions or no solution. Okay, so we'll look at these two. So right here, we have y is equal to -x plus 2. So let's go ahead and try substituting that in. We get 2x plus, now it's 2 times y, so I'm going to do 2 times that whole thing, -x plus 2 equals 4. So here I get 2x minus 2x plus 4 equals 4. Notice the variables end up going away because 2x minus 2x would be 0. So I get 4 equals 4, which is a true statement. when we have a true statement, when the variables disappear, this means we have infinitely many solutions. Okay, so let's take a look at what happens when we have no solution. So we're going to use substitution. Now, first thing, I do not have a variable isolated, so maybe what I'll do is I will isolate x in the second equation just because it's easier. So I'm going to subtract y from both sides. So I get x equals, you can write that as -3 or negative y plus 3 or 3 minus y, it doesn't matter. And now I want to take this 3 minus y and plug that into the first equation. So it's not necessarily that you're taking the first or the second equation. You take whichever one is easier to solve for. Okay, so I have 3 times 3 minus y plus 3y equals 6. So I get 9 minus 3y plus 3y equals 6. So this time the variable disappears, but I end up with a false statement. Right? 9 not equal to 6. That implies that there is no solution. Okay, so true statement, infinitely many. False statement, no solution. Okay, again, if you want to pause it here and try these on your own, or you can follow along. So here I have x is isolated. I'm going to plug that in. So I have 2 times 1 minus 4y plus 7y equals 3. Go ahead and distribute. I'm going to combine like terms. Subtract 2 from both sides. And I got to get rid of that negative sign. So I get y is -1. I have to find my x value. So I'm going to plug -1. I'm going to plug -1 into that second equation. So that's going to give us 1 plus 4. So x is 5. So we'll put that together and get 5 -1. Okay, let's plug this in. This time I'm going to plug in 3x plus 2. I'm going to substitute that in for y. So I have 6x minus 6x minus 4 equals -4. So these are going to cancel. I get -4 equals -4. That means there are infinitely many solutions. Okay, I got y isolated, so I'm going to substitute that in. So 3x minus 5 times 3/5 x equals 15. So I get 3x, and then actually we'll get minus 3x. So we get 0 equals 15. That means there's no solution here. Okay, one more of these. Let's go ahead and isolate, maybe we'll isolate A. Again, you can isolate B if you prefer. So I get A equals 1 minus B. So I'm going to take this and I'm going to substitute it into the second equation. So I have 5 times 1 minus B plus 3B equals -1. Go ahead and distribute. I'm going to combine the negative 5b and the plus 3b. Okay, go ahead and divide both sides by negative 2. And we should get b equals 3. And so I'm going to substitute that back into the first equation. So I have a plus 3 equals 1. So I get negative 2 for a. Now, I didn't give you x and y this time. I gave you an a and a b. So whenever you're doing the ordered pairs, you always want to make sure they're just an alphabetical order. So I'm going to put the negative 2 and then the 3. All right. So just a quick note. Ordered pairs always go in alphabetical order. All right, last thing here. Couple word problems. All right, so it says the sum of the measures, or sum of the measures of angles x and y is 180 degrees. The measure of angle x is 24 degrees greater than the measure of angle y. We want to define the variables and write a system of equations. Well, the actual variables are already defined for us. Okay, so what we're going to do is let's take the two sentences. So it says the sum of the measures of angles x and y is 180. That means x plus y, right? That's what sum means. That's our equals, 180. Don't worry about the degrees for now. We'll put that in at the end. Then it says the measure of angle x is, so x is 24 degrees greater than the measure of angle y. That means we are adding 24 degrees to angle y. Now we want to find each measure. So I am going to take y plus 24 and I'm going to substitute that into the first equation because I have x is already isolated for that one. So I have y plus 24 plus y equals 180. Combine those two y's and then solve for y. So I'm going to subtract 24 and get 2y equals 156. Divide by 2 and I get 78, and then I'll put the degree symbol here. And the other angle, well, remember, x was equal to y plus 24. Again, you can use that first equation if you like. So 78 plus 24, angle x ends up being 102 degrees. So our two angles are 78 degrees and 102. Okay, we want to find the value of xy given the following system of equations. Okay, so that means we actually have to figure out what x and y are first and then multiply them together, right? That's what that means. Okay, first thing, I'm going to take the first equation, I'm going to isolate x. So I'm going to add y to both sides. So I get x equals 8 plus y. I'm going to take that and substitute that into my second equation. So I have 8 plus y equals 14. Okay, go ahead and solve. Okay, I got y equals 3. Now I want to solve for x. Maybe I'll use that second equation this time. X plus y equals 14. And I get 11. So which one represents xy? Xy would be 11 times 3, which gives us 33. Okay, so go finish up the paired deck and make sure that you finish that for the rest of the lesson, and then there's a worksheet for homework.